Okay, hello, welcome back. This is part one again, or day one. I'm gonna revisit day one. So there's a comment in my course. Someone asked if I could revisit day one. We've got this get nums that sum to problem here, and the question was, can we make this run faster? So I'm gonna do that if I can. We're going to talk about runtime complexity here. The runtime complexity of this function right here, get nums that sum to, is taking a sequence, which is a list of numbers. So if you consider that sequence to be of length n, we're looping over that sequence twice. So for every item in the sequence, we're looping over it again. Runtime efficiency of this is n squared. Can we make this faster? Yeah, we can. And so here's the algorithm of how I'm going to make it faster. I posit that I can do this in time O of n, big O of n. And how I'm going to do that is I'm going to leverage a set. So while I'm looping, I'm going to only loop over one time. While I'm looping over, I'm going to keep track of what I've seen. So I'm going to make a trade-off. I'm going to use maybe a little bit more memory because I'm going to make another data structure. And I already have a sequence in memory. So I'm potentially doubling, if not more, since I'm using a set to hold that again. But I'm going to keep everything I've seen in a set, and then I know what number I'm looking for to complete that sum. It's the number that I've seen, or 2020 minus the number that I've seen. I'm going to see if that's in the set. If that's in the set, then I'm already done and I can break out. So that will give me a runtime of n. So let's do that. I'm going to go up here, and I'll just copy this and I'll make a new one here that's called get nums that sum to, and I'll call this fast. Okay, and I'm going to get rid of all of this here. And this is what it's going to look like. I'm going to keep track of what I've seen. I'm going to use a set to do that, not a dictionary. So here's a set. I need to use the set constructor because there's no empty set literal. Then I'm going to say for val in seek, and I'm going to say scene.add, and I'm going to add val to it. Okay, and then what I want to do is I want to say if sum result minus val, if this result is in scene, then we're done. All we have to do is return val and this sum result minus val. Okay, so that should be part one, and that should run in runtime one. I'm going to update this. I have this code down here to run it. I've got another one that will run it fast here. So I'm just going to print out res, which is our previous one, and res2, which is our fast one. And let's make sure that they both give the same answer here. Okay, and I got invalid literal here. That's because I need to run it with the input at the end there. And it looks like I did get the same thing. Well, they're in different order, but I got 947 and 1073. So that looks like it did work. So that's runtime of n. So that's quite an improvement on that one. Now, what about the second one here, part two? Part two is with 3 numbers. Can I make part 2 faster? I think I can make part 2 faster. And I think I deleted part 2. So part 2 had a triple nested loop. Let me just, what I'm going to do is I'm going to copy this. I'll paste this in my scratch buffer. I'll go back to here and see if I can pull it back out here. Okay, there's part 2. So here's part 2. Okay, so the runtime of part 2 here, let me just put the fast part here from the scratch back in here. I'll upload this back in here. Okay, it looks like I guess I got that twice. Okay, weird. Okay, so here's part 2. Part 2, we're looping over this 3 times. So I've actually, in the meantime, I've seen another combination that is probably a little bit better that I like here. Also note that there is a bug in this that many people have noted. This should be I is equal, if this is equal to that, or J is equal to K. In our case, it actually doesn't change the answer because the data doesn't have that answer come out. But that was a bug, so we can fix that. Now, let me talk about another solution that I've seen here, and I'm going to call this the combinatoric solution. So in Python, there is a file or a module that will give you combinatorics. So that is in collections, I believe. Okay, and you can see that we have in there, we don't have combinations in there. Maybe it's in functools. Oh, it's in iter tools. My bad. Okay, so let's look in iter tools, and there it is, combinations. Let's get the documentation for that. Okay, and you give it some iterable and the R length combinations of that. So we should be able to say for val1, val2, val3 in iter tools dot combinations. And we're going to say seek, and we're going to say 3. And then we'll just take this logic from down here. Okay, so this, we call this part 2 comb. So let's put this part 2 in here, and I'm going to uncomment the original one, and I'm going to make a res2 just to see verify that we got the same here. Part 2 comb, and we'll print out res2. So this is Python day 1. And import functools. I keep doing that. I need to pass in input. Okay, no iter tools defined. Let's import iter tools up here. Okay, and there's our numbers, and you can see that we got the same numbers there. So yeah, I prefer this combination version here. So if you remember that in iter tools there's combinations, you can use that. Now, Should we do a fast version of this? What would a fast version look like? A fast version, instead of doing looping over all three, we could loop over two of them, and then we could keep track of that, similar to this up here. So it's going to look very similar to this up here, except instead of having one loop, we're going to do two loops, and then we're just checking that. So maybe I'll just leave that as an exercise to the reader. That should speed that up if you want to use that. So hopefully this was useful, giving you a little bit more insight, also fixing my bug that many people noticed. So thanks for reader comments, and good luck. Bye.